Good morning to all of you. In today's lecture, I am going to explain structural elements of finite automata. Before going to learning automata theory, so first, what is the basic definition of finite state machine? So, what is the finite automata? The basic idea behind to design the any automations for the different languages. So, what is the automation? So, an automation or finite state machine is nothing but an automaton with finite number of states is said to be finite state machine. So, what is the definition of finite state machine? An automaton an automaton with a finite number of states, an automaton with finite number of states so is called finite state machine. Finite state machine. So an automaton with a finite number of states is called finite state machine. So coming to structural elements of finite state machine, next topic is structural elements of finite automata. In the structural elements in finite automata, so we have three components. Input tape. The second component of finite automata, read or write head. The third component is finite control. So these three components I will explain with the block diagram. I'm going to explain. Finite state control. The first component is input tape. Here input tape is divided into squares. Input tape is divided into squares. Each square contains a single symbol. Each square contains a single symbol. The end squares, so these are the end squares, left hand marker. So here the end squares of this tape contains end marker. This is the left end marker. Here dollar is right end marker. Between these end marker, between these end markers, the tape is said to be input string. This is input string. Between end markers, it indicates that the tape is either infinite length of the string or finite length of the string. Without end markers, that input string is said to be infinite length. Between end markers, that means using end markers between them, the string is finite length of the symbols, having finite length. So that is the difference. Okay. Next, coming to second component of finite state machine, that is read write. So what is the role of this read write head? Here the read write head is pointing to pointing a single symbol. So the read write head examines. So this read write head examines only one square at a time and can move. It can move either to left or to right direction. Either to move right direction or left direction, one position. So explain input tape, read write head. It's coming to finite state control. So sometimes we call finite control also. The finite state control is that it is the responsible for controlling the total functioning of the machine, total functioning of the machine. So it will decides whether the input string is accepted by this machine or rejected by this machine. Whether the given string is accepted by machine or rejected with the help of finite state control. So these are the basic components of finite state machine. So I repeat again once, what is the finite state machine? An automaton with finite number of states is called finite state machine. In finite state machine, we have three elements, basic elements or basic components: input tape, read write head, finite control. Coming to input tape, the input tape is divided into squares. Each square represents a symbol, single symbol. So here we are using end markers also, left hand marker and right hand markers. So without end markers, the string is said to be as infinite length. With using end markers, the string is also called as finite length of the string. So this is the input string. So coming to second component of the finite state machine, read write head. So read write head, what is the role of read write head? The read write head just examines every time only one square at a time and can move to either left direction or right direction. That means it can move only one position either to right or left. So after reading the symbol. Next, coming to finite state control. This finite state control is the overall responsible of the total functioning of the machine. It will decide whether the input symbol or input string is accepted by this machine or not. Okay. In coming class, I will explain the central concepts of, in next class, I will explain the central concepts of finite automata. In this lecture, I am going to explain central concepts of automata theory. In previous sessions, already we have learned what are the components of finite state machine. In this lecture, I am going to explain central concepts of automata theory. So the basic central concepts, that means the first and foremost concepts in automata theory. So is alphabets, strings, languages. First, I am explaining alphabet. So, what is the alphabet? So, how to represent alphabets in automata theory? Alphabet is nothing but a set of symbols, set of symbols So which are always finite, which are always finite. So these alphabets are symbolically represented using sigma. So the notation for alphabet is sigma. For example, I am considering sigma equal to set 0, comma 1. So in this input, this is input alphabet. This input alphabet having only two symbols 0, 1. This is also called as binary input alphabet. Binary input alphabet. Binary input alphabet. I am considering another example. Sigma equal to A, comma B. So this is the input alphabet which are always finite. A, B. Another example of input alphabet is 0, 1, 2, 3 and so on 9. So in this alphabet, this is also called as decimal input alphabet. Decimal input alphabet. Decimal means, so decimal number system having 10 symbols. 10 symbols. We have 10 symbols. Here alphabet is nothing but the definition of this alphabet is set of symbols which are finite. For example, sigma equal to 0, comma 1, sigma equal to A, comma B, sigma equal to 0, 1, 2, 3 and so on 9. For example, another example of natural language, sigma A equal to A to Z. So in this this is called alpha. So in this English language, for example, if you want to design language, we need alphabet. That means we need input. Alphabet is nothing but some input. The input is represented as using set. That set is finite length. Next, coming to another concept, that is strings. What is string? The strings are nothing but sequence of symbols or sequence of letters from alphabet. Here the sequence of symbols from alphabet. For example, sigma equal to 0, comma 1. So using this input alphabet, we derive so many strings, like strings. 0 is a string, 1 is a string, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 0, like that. Okay. So these are the strings. Strings means set of symbols from input alphabet called strings. The definition of string is nothing but sequence of symbols taken from alphabet or over the alphabet is said to be strings. Okay. Next, I am explaining some operations are done on strings. So, okay, next class I will explain what are the basic concepts or operations on strings, like how to calculate the length of the strings, concatenation of the strings, and so on. Okay, thank you. Next class I will explain remaining topics.